Yes, hello. We welcome you back to PSSB, Physical Sciences, Silver Bullet. Is Richard once again. Now, today we are looking at this case. Um, and please, if you have not yet subscribed to the channel, please do so. We believe it's to your benefit, it's to your advantage, because it means that um, every video we release will be just accessible to you at first glance. So what we are having here is a case. We are having a van of mass 2000 kg traveling up a hill, inclined at that. So we have the mass there, you have the angle of inclination, and the speed is constant and is 10 meters per second. The van experiences a constant friction force of 200 newtons. Okay. The question says, calculate the power output of the engine of the van. Okay. So what do you do here? How do you go about this? There is some important information you need to consider here before you do anything. First of all, the question is looking for power output. That's very important to know. And there's something else which is important here. Look at here. That is constant speed. We have to know that speed is substitutable for velocity if the body is moving in a straight line. Actually, we normally say speed and velocity are brothers and sisters. So what do we do here? Okay, good people, we are calculating power and we are having constant velocity. Okay, what comes to your mind is that we are having the formula. We are going to be using the formula P is equal to FAV, where P is power expended, FA is force applied, not any other force, is force applied, and V is the velocity. Now you should ask yourself, under what circumstance do we use this formula? We use it when we are experiencing constant velocity or constant speed. So under that circumstance, what do we do? Let us look at the data. When you look at our data, this is what we know. We know mass, which is 2000 kg. We know angle of inclination, which is 20 degrees. We know speed. We said you can substitute with the velocity, which is 10 meters per second. We know friction force, which is 200 newtons. Okay. So if you have this information here all together, and you look at the equation we are going to be using, what comes to your mind? I want you to remember that velocity was given. This velocity was given. So the giving of the velocity means that whatever we are going to do under this question is going to be to determine force applied. That is our goal. That is our absolute goal. We get that one, it is case done. It's gone. The case is done. So what do we do here? What do? We look at our incline. Okay, that's what we are having for the incline. we are having the body going up. Okay. And we indicate all the forces which are acting here. I normally tell people that here you have to apply some bit of imagination. We are having a body which is going upwards at constant velocity. The question is, can a body go up the incline at constant velocity without applied force? Unless you're a magician, the answer is no. So we have applied force here. It was not mentioned, but we know it is there. What else do we have? We prefer to use components. So we have the component, which is Fg parallel. We are given the friction force, so we have Fk also acting on this surface. Okay, so that's what we are having. Yes, there are other forces which are acting, but we are not going to put them because these are the forces we need. Yes, we'll have normal force and Fg perpendicular because we're using components, but we are not going to put them. Okay, now with this information, how do we get force applied? Remember, the entire case is about getting force applied. Once you have force applied, the case is done. So you bring your net force. You say F net is equal to Fa cos 0 degrees. Y is in the direction of displacement. You have Fk cos what? 180 degrees. It's opposite the direction of displacement. You have what? Fg parallel cos 180 degrees. Why? It is opposite the direction of displacement. From here, what do you get? You're going to get F net is equal to Fa minus Fk minus Fg parallel. Okay? But there's something you have to note. The body is moving with uniform velocity. You understand me? Constant velocity, what does it mean to a scientist? It means this. It means that acceleration is 0. It also means that if acceleration is 0, therefore F net is also 0. Okay. So from there, what do we have? We are having 0 as our F net in the expression, and we are going to have Fa minus Fk minus Fg parallel. You have to remember that Fg parallel is mg sine alpha. So what do we do here? You make your Fa the subject of the formula. So what do we have here? We are going to have Fa is equal to what? Fg, okay, we said this one is mg sine alpha plus Fk. So when you reach this level, what do we do? You check for what you have. Remember, we are looking for this. Do I have mass? Yes. G is constant. We know alpha. We know Fk. So everything here is known. What is pending is substitution. So you substitute and get Fa, then you use it in the formula. Let's substitute and see what we get. So this is what we get after substitution. And what does it represent? This one represents our applied force. And so our equation comes up. What's the equation? Power is equal to FAV, which is going to be 6 903.59 times the velocity, which is what? Which is 10. What you get there will be the power in watts. So this is the power expended by our engine. And yes, that marks the end of the video. The channel is PSSB, Physical Sciences Silver Bullet, and it's Richard behind the channel. If you have not yet subscribed to our channel, please do so.